In this video, we're going to examine current, voltage and resistance, what they are and how we measure them in an electrical circuit. What you'll need for this session: you'll need pen, paper, internet access and your computer. The aims of this video are to recognise the flow of electricity as the movement of electrons around a circuit, that voltage is the energy needed for electrons to travel through a component in a circuit, that resistance is anything that opposes the flow of electrons, So what is current? Well, current is defined as the rate of flow of electric charges in a circuit. But of course we need to know what these electric charges are. These electric charges are electrons. They are the negatively charged particles that orbit the nucleus of an atom. And of course, to do work, the electrons must move in a complete circuit. So we think of it as being like a circle, and the electrons can move through that circle. So how do we know when a current is flowing in a circuit that we've set up? Well, of course, here's a simple circuit with just a battery to provide some energy and a globe. And of course, we know that it's complete when the globe lights. Current flows when electrons move through a complete circuit. Here's a diagram of electron flow through a circuit containing a globe and a battery. And here's an animation showing the direction of flow, direction of movement of the electrons through the circuit. And they flow from the negative to the positive terminal. So how do we measure current? Well, we measure current using an instrument called an ammeter, or more commonly known as an ammeter. And here's a picture of one that we use in the laboratory. What does it do? It measures current. The unit of measurement of current is the ampere. Symbol for the unit is capital A. And we always connect an ammeter in series in the circuit in order for it to measure the current correctly. So how do we connect an ammeter correctly? Here's a diagram of an ammeter correctly placed in the circuit. You can see that the circuit contains a battery here. It has a globe over here and a graphite rod here. This circuit could be testing to see if graphite actually conducts electricity. Notice the ammeter is placed here in the circuit in series with all of the other components. This is the correct way to connect an ammeter into an electrical circuit. So it must be connected in series with the other components in order for us to get a correct reading of the current in the circuit. So what exactly is voltage? Voltage is a measure of the push that the electrons obtain from the battery or from a power pack. The higher the voltage, the more energy the electrons are carrying. Voltage is measured in a unit called the volt, and the symbol for volts is V. In this animation, we can see we have a circuit with a 6-volt battery and a 6-volt light globe. The red rectangles passing through the battery and around the circuit represent each electron as it flows through the battery, along the wires, to the globe and back to the battery again. To the right of the battery, we can see that inside the rectangles there are 6 circles. These represent the 6 volts of energy that each electron is picking up every time it passes through the battery. This voltage, the electrical energy supplied by the battery, is then used up by the component, in this case a 6-volt light globe. And we see as the electrons pass into the light globe and out the other side to the left, they no longer contain the circles. The electrical energy has been transformed into light and heat energy in the globe. The electrons then return to the 6-volt battery and pick up 6 more volts of energy as they flow through. This continues as long as the circuit is complete and as long as the battery can continue to supply energy. Now, how do we connect a voltmeter into a circuit to measure our voltage? Well, here's a circuit with a 2-volt battery, a switch, a light globe, and a voltmeter. Notice how the voltmeter is connected across the component, or more correctly, in parallel to the component. So the voltmeter measures the energy being used up as the electrons travel through a component in a circuit. It must be connected across, or more correctly, in parallel to a component. What is resistance? Well, resistance is anything that opposes the flow of electrons. Resistance causes the electrons to lose some of their energy. The components in a circuit all resist the flow of electrons. They make it more difficult for the electrons to flow through them, and therefore the electrons will use some of their electrical energy. The higher the resistance, the more energy the electrons will lose. This electrical energy, though, is transformed into heat, light, kinetic or sound energy in the component, and this can be of use to us. The unit of resistance is the ohm, symbol omega, which is a Greek letter. Remember our 6-volt battery and 6-volt globe that we were looking at earlier. Here it is again, and now we can talk about this in terms of resistance. So we already know that we've got electrons flowing through the 6-volt battery and picking up the voltage, the electrical energy, and that battery is giving them the push, the energy to continue travelling around the circuit. However, when they reach the 6-volt globe, it has resistance. It causes the electrons to use up their energy by transforming it from electrical energy into light and heat as they travel through the globe. This transformation of the energy, causing it to change from electrical into light and heat, is what we term resistance. And any component in a circuit, whether it's a globe, a motor, a buzzer, or any other kind of component that we might want to put into a circuit, it will have resistance. That means it will cause the electrons to transfer their energy. In the wires, we have very low resistance because we don't want our electrons to use up their energy before they reach the components. So wires in a circuit will always have very little or no resistance. Okay, that's all for now. If you want to know more, then there are some great websites you can visit. Here are a few to get you started.